Hi everyone, welcome to Rakesh sir lecture. Today we are going to discuss about a spectacle versus ocular accommodation in hypermetropia, and it is a continuous lecture of the previous classes. In previous classes we have learned about a spectacle versus ocular accommodations in myopia and emmetropia. So today we are going to learn in detail about in hypermetropia what are how the ocular accommodations and spectacle accommodation occurs. Okay, so let me first discuss about the spectacle accommodation in hypermetropia, then we'll discuss about ocular accommodation in hypermetropia, and then we'll compare both, right? So for that, let me draw the eye. So what is this? Hypermetropic eye, right? And here one more I will draw. This is also hypermetropic eye. Now this hypermetropic eye, once the way of understanding this is, once we talk about accommodations, we have to take the two scenario, like one, the eye should be focused at distance, and then the eye should be focused for near, and then we'll see the difference in the accommodation between the both when the eye is focused for distance and when the eye is focused for near, and we'll see the difference in that, and that difference should be compensated by accommodations. That difference is not the difference is accommodations. Okay, so what is, so let me first, this hyperopic eye is focused for distance. So let's assume this is hypermetropic eye. This is focused for distance, and this hypermetropic eye is focused for near. This hypermetropic eye is focused for near. Now what we will say is and this is let's first discuss about the spectacle accommodation. Okay, so in a spectacle accommodations, let's assume this hypermetropic eye is corrected with plus 10 diopter of lens, right? So in this plus 10 diopter of lens, when this eye is focused for distance, that means the light is coming from infinity or distance object, that is optical infinity or more than 6 meter. Okay, so the light is coming here, and if I want to find out the spectacle accommodation, so I need to find out the vergence of light at the spectacle plane, right? So this is, we know a spectacle accommodation formula is a spectacal accommodation is equal to vergence at distance minus vergence to near. So vergence of this is for distance, and vergence at a spectacle plane when the eye is focused for distance. So this at this vergence, what is the vergence of light here? So from as in the earlier lectures I have told that when we need to calculate the vergence of light at some plane, so we need to find out the distance from that plane to the respective object or image point, right? So now you see here, this is the plane here, this is a spectacle plane. Let's yes dash is the spectacle plane, yes dash, yeah. And from this plane the object is situated at infinity, so the distance from this plane to infinity is infinity, so the vergence at this point will be reciprocal of the distance, right? When you want to calculate the vergence, that means you just reciprocal the distance, you will get the vergence. And when you want to calculate the distance from the respective vergence, you do the reciprocal of vergence power, you will get the vergence length, or that is the distance you will get, right? So now we need to, we know the distance, it is infinity, object is at infinity, and we need to calculate the vergence of light at this point. So we'll do reciprocal of this distance, that is vergence at d is equal to 1 by infinity is equal to 0. Are you getting it? Or something I can write here better. So Vd is equal to 1 by infinity, that is equal to 0. So here Vd is equal to 0, vergence of light is equal to 0. I'm not talking about the vergence of light at this plane, okay, or a spectacle plane, but this lens has power of plus 10 diopter. Don't forget, just we are taking the example of a plus 10 diopter. That doesn't play a significant role, because any of the power if you take, the vergence will be 0 only, because it is the when we are calculating the vergence of light at the spectacle plane, we are not there is no role of power of lens. There is no role of power of lens. It is just the reciprocal of distance. So this we got Vd. Now we are going to say about versions of light at when the eye is focused for near. So this is the spectacle plane. Here the plus 10 diopter lens is there, right? So in this, when the light is focused for near object, let's assume this is at how much centimeter? 40 centimeter. This is at 40 centimeter, and this 40 centimeter, it is divergent light ray. This one is divergent light ray, and you are seeing this. I want to calculate the spectacle plane versions of light. So from this plane, this object is situated at 40 centimeter, and that toward left side. So this distance will be considered as negative. So let's assume this is minus 40 centimeter. Okay. Now the second things I want to find out the versions of light at this plane, at a spectacle plane. So I will just reciprocal of this distance. So if I reciprocate this distance, so what I will get? So 100 by, it is in centimeter, right? Minus 40 centimeters. So directly I can do 100 by 40 minus 40. So you will get Vn. This is for Vn. So Vn is equal to 100 by minus 40 is minus 2.50 diopter. Right? So here I can write is Vn is equal to 100 by minus 40, that is minus 2.50 diopter. So what you understood from this? The versions of light reaching to the spectacle plane is minus 2.5 when the hypermetropic spectacle corrected eye is focused at 40 centimeter. Okay. Now see here, when the hypermetropic eye corrected with a spectacle focused for distance, the versions of light at a spectacle plane is 0. Okay, so if I want to find out the spectacle accommodation, we know our earlier formula Vd minus V1. So if I proceed this, Vd is 0 minus Vn is minus 2.50. So it will become minus into minus plus. So plus 2.50 diopter. This is spectacle accommodation. Am I right? Yeah. Or you can put here yes A equal to Vd minus Vn, and this is equal to 0 minus minus 2.50, and this is equal to plus 2.50 diopter. So spectacle accommodations, because there is change in versions between distance when eye is focused for distance and when the eye is focused for near, the change in versions by 2.5 diopter. So this same diopter accommodation should be required to come to make the light to focus on the retina, because when the eye, say distance eye, it is conjugate with retina, distance light it is conjugate with retina, but when this hypermetropic eye is focused for near at 40 centimeter, this because of this divergent, if the light is if the distance light is focusing on the retina, let's assume this is focusing on the retina, so in these conditions the light will get more diverge. Light will get more diverge because of this divergence, minus 2.5 divergence. So to nullify this minus 2.5, there should be some mechanism to nullify this, and light should be brought up to the retina, brought back to the retina, right? So that mechanism is called accommodation. So if it is minus, to nullify it, we should have plus accommodations. So plus change in power of lens, right? So this is about spectacle accommodation. I hope the concept got clear about spectacle accommodation. Now we'll go for ocular accommodation in hypermetropia, and that is very, very important. But that is the accommodation which really exists, right? Spectacle accommodations doesn't really exist, right? But ocular accommodation really exists. So okay, so I'll erase this now, and we'll go forward to understand about ocular accommodation in hypermetropia. So So let's assume this is two eye we have to make. One eye should be focused for distance and other should focus for near. So let's assume this is a hypermetropic eye which is focused for distance, and one more eye we have to draw which this should be focused for near, right? And of course this eye is corrected with plus lens, and here also the eye should be corrected with plus lens. Okay, now what is we are saying is, for this, as this hypermetropic eye is focused for distance, so the from distance what kind of light ray will come? Parallel light ray, right? So parallel ray of light which is coming from infinity or from distance object, once it strikes at this plus 10 diopter lens, see, as it is parallel ray of light, the versions of light reaching at this lens will be 0. But once this light will emerge out of this lens, what will be the versions of light at this plane? So once the light is emerging out, it is the summation of the versions of light. It is a summation of versions of light which before entering the lens, that is 0, plus the power of the lens, so it is plus 10. So the versions of light which is emitting out of this lens will have how much? Plus 10 diopter. Okay, the versions of light which is emitting out from this lens is plus 10 diopter, and if it is the versions of light is emitting out is plus 10 diopter, then it aims to focus at 10 centimeter. Versions length will be 10 centimeter, because if you reverse the power you will get the distance. So here I can keep here as this distance. Okay, from this lens, yeah, from lens this distance is how much? 10 centimeter. Let's assume this distance is how much? 10 centimeter. But in ocular accommodations we are measuring the versions of light at principal plane. Okay, so now I want to find out the versions of light at this plane. And how will you find out versions of light at this plane? So to get the versions we need to find out first distance and either object point or image point. So here this is versions of light. This is the versions of light, and this versions of light, how much distance from earlier lectures we have discussed, right? Vertex distance plus this from corneal apex to this principal plane, total is approx 15 mm, which approx is 1.5 centimeter. So total distance is 10 centimeter, right? And if this is 1.5 centimeter, so what will be this from principal plane? Let's p dash is the principal plane. So at the principal plane, how much versions we have? We have first we need from distance from principal plane to this image plane is how much? 10 minus 1.5, so it will become 8.5 centimeter, right? And if I do the reciprocal of 8.5 centimeter, you will get the versions at this point, right? And from this plane, this 8.5 centimeter is toward the right side of the lens, so this 8.5 centimeters should be positive. So let's calculate the versions of light. The versions of light at principal plane is given by if it is in centimeter, 8.5 centimeter, so reciprocal will do directly by 100 by 8.5, so it's given by 100 by 8.5. it is approximately how much? Okay, let me calculate this. 100 by 8.5, 100 by 8.5. It is 11.76 diopter. Okay, so it is 11.76 diopter. 11.76 diopter, and this will be plus because this distance is plus. So that means at this plane we have a power of plus 11.76 diopter, right? So when the eye is focused for distance, now similar things we'll find out for near, and then we'll see the difference, how much it is there, and that difference will be compensated by accommodation. That same opposite diopter should be accommodation. So let us, this eye is focused for near object. Near object is at 40 centimeter from the spectacle plane. So this distance, this is object point O, and from here this is the spectacle plane. The distance is how much? 40 centimeter. And from this spectacle plane, as this is 40 centimeter, right, as this is 40 centimeter, what will happen here is the divergence of light reaching at this spectacle plane is just reciprocal of this distance, and from this spectacle plane, as this distance is toward left side, this distance will be considered as negative. And so the divergence we need to calculate means the divergence will be divergence at a spectacle plane, VSP. Divergence at a spectacle plane is how much? 100 by 40. You will find, you will get 100 by minus 40, so you will get minus 2.50 diopter. Okay, now I need to calculate the divergence of light which is emerging out of this lens. Okay, at approximately at this, when the light is emerging out of this lens. Okay, so that means when the light has to emerge out of this lens, that time the combination of the divergence of light striking the lens and the power of this lens, the total power of the lens, the both sum and both sum will be there, right? So if this is plus 10 diopter, as we know, this is the lens has plus 10 diopter, and this is minus 2.5 diopter. So the divergence of light which will emit out, right? The divergence of light, emerging out of lens is given by what is there? Minus 2.50 diopter plus 10 diopter, summation of both. So it will be plus 7.50 diopter. That means plus 7.50 diopter light will be emerging out. So if the plus 7.50 diopter light will be emerging out, they aim to focus at some point, right? They aim to focus at some point, and this point, let's assume this lens is aims to focus with a diopter of 7.5. So what will be this length? So as I told earlier, we know the divergence. Then if you do reciprocal means we will get this image point, right? So divergence is how much? Plus 7.50 diopter. So the divergence length will be how much? Reciprocal of this power. Are you getting it? So reciprocal of this power. So reciprocal of 7.5, how much you will get? So as this 7.5 is in centimeter, I can directly do by 100 by 7.5, right? So 100 by 7.5, it is 13.33 diopter. So 13.33 diopter. So this now will be the distance from this spectacle plane, or from the lens till it will be 13.33, sorry, centimeter. It will be centimeter, right, to the image plane. So a spectacle plane to image plane, the distance is, total distance is 13.33 centimeter. Now, but to calculate the ocular accommodation, we need to get the divergence at principal plane. So we need to find out the divergence at principal plane, at this plane, at principal plane. So at this plane, to find out the divergence, first you should get the distance, and then if you do reciprocal of that distance, you will get divergence. So How will you find out this distance from principal plane to image plane? So the distance between principal plane to image plane is given by total distance from a spectacle plane to image plane minus this distance. Approx to vertex distance, it is how much? 1.5 centimeter. So 13.33 centimeter minus 1.5 centimeter. So the remaining distance from here, principal plane to this will be 13.33 minus 1.5. How much it will become? 12.83, right? 12.83 centimeter. Just cross check. 13.33 minus 1.5. Yeah, it is 11.83. It's not 12.83, it's 11. It's better to recheck always. So it's 11.83. Here this is 11.83 centimeter. So once we know this distance, just reciprocal this distance to get the vergence at principal plane. Now the vergence of light at principal plane, the vergence of light at principal plane is given by what? 100 by, how much is that? 11.83. 100 by 11.83. And as this distance is from this plane is toward the right side, this distance will be considered as positive. So how much it will become? We'll calculate once more. So 100 by 11.83. 100 divide 11.83. It is 8.45. 8.45. So plus 8.45 diopter. Plus 8.45 diopter. Are you getting this? Now here it is plus this vergence at this plus 8.45 diopter. Now see here, the vergence of light at principal plane when the eye is focused for distance is plus 11.76, but when it is this eye is focused for near, their vergence decreased to 8.45 diopter. That means there is decrease in the vergence, or decrease in the plus power, or increase in the minus power, right? But by how much? So there is decreased by, we have to get the difference, and that difference there is decreased by 11.876, right? 11.76 minus 8.45, you will get 3.31. So there is difference how much? 3.31. So 3.31 diopter plus power decreases, that means minus power has increased. So this much minus power made this light to fall more beyond than the previous one. Are you getting it? This much, so it is falling more behind. So now what is there means we have to make this light to fall on the retina. So that means whatever the increased minus power is there, increased minus power or decreased plus power is there by 3.31 diopter, that should be compensated by the accommodation, right? That should be compensated by accommodation. So that means how much diopter of accommodation this eye should do when it is seeing for 40 centimeter? They will do how much? 3.31. So ocular accommodation is given by Vd minus Vn. Vd is how much? Plus 11.76 minus this Vn is, this is Vn, right? So Vn is plus 8.45, right? So plus, we have seen minus into plus minus, so plus 11.76 minus 8.45, so it will become plus 3.31 diopter. So this is the ocular accommodation. So spectacle accommodation in hypermetropic is 2.5 and ocular accommodation is 3.31. That means as compared to metrop, see the moral of this derivations or concept behind this is you you will tend to do more accommodation in spectacle corrected hypermetropic eye as compared to emmetrop. You have seen in emmetrop ocular accommodation is 2.41 diopter, but in myop, sorry, in hypermetropic it is 3.31 diopter. Okay, so yeah, this is the things. Hypermetropic eye, spectacle corrected eye will do more accommodation as compared to emmetrop. This is the all overall summary of this, and this will be asked in essay questions. So when it will be asked in essay questions, whatever the diagram you have drawn, first you have to write in the form of word, and uh, and then you have to go for this derivation. Okay, when you're writing in the form of word, just include this vertex distance also, give the name of the plane, some point, L dash for lens, P dash for principal plane, like that, some plane for this image. Okay, like I dash for the image plane, something like that. You have to do this. Now at last I want to summarize all the, it's worth to summarize, because we have studied the derivation for a spectacle versus ocular accommodation in emmetropia, myopia and hypermetropia. Three things we have completed, and each will be asked in essay questions. So now I need to summarize or recap all these things what we have learned till now. Okay, so I will erase this and then I will summarize and we'll wind up with the lecture. So what we have learned till now. So till now in spectacle accommodations and in ocular accommodation, we have learned that spectacle accommodation in emmetropia is how much? Plus 2.50 diopter, and this will be for myopia also, and this will be for hypermetropia also. It remains same as we have seen during our lectures, right? Now coming to ocular accommodation, in emmetropia you will have plus 2.41 diopter. In myopia we have how much? Plus 1.83 diopter approx. And in hypermetropia we have plus 3.31 diopter approx, right? So the conclusion of this all derivations and lecture is ocular accommodation for emmetropia is less as compared to hypermetropic eye. That means once you wear the hypermetropic glass, right, that means you tend to accommodate more as compared to emmetrop. But once you wear the myopic glasses, you tends to accommodate less. As compared to emmetropia. So this is the conclusion. And how much less? Just imagine how much difference is there? 2.41 minus 1.83. The difference is how much? 2.41 minus 1.83. It is 0.58. That means it is doing 0.58 less. And what is this difference from emmetrop? Emmetrop 3.31. 0.9. So 0.9 diopter here, right? Approx 0.9 diopter. So that means, see, in clinicals it is said that even 0.25 difference is considered as clinical significant value, but here the difference is up to 1 diopter, near to 1 diopter and near to 0.5 diopter. So that means there is clinically significant amount of change in accommodations when you wear glasses as compared to emmetropia. but both emmetropic eye they are also seeing at 40 centimeter, and this both spectacle corrected eye also seeing at 40 centimeter, but there is clinically significant amount of change in accommodation. So this is the main conclusion of the story, a main conclusion of this lecture. One more thing I want to highlight: what is the importance of this spectacle accommodation? What do you think? What is the importance of this spectacle accommodations? There is no importance. I don't know why it has been taught in this lecture as a part of the syllabus. Why it should be why it should be taught? It should be it's ideally it should not be taught, because a spectacle accommodation is the imaginary hypothetical accommodations. There is no real existence of these accommodations. The real existence is ocular accommodations. When the light versions of light we are calculating, when the power of light is just before the crystalline lens, then okay, this is the existence. But there is no existence of this spectacle things what we have discussed earlier. So this you can just think this is one imaginary accommodations. It doesn't exist. We author or we scientist or we investigator have created this. Okay, not you just imagine we created this. Yeah, we have created this, and we are then first we have created this theoretically, and then we are comparing with this ocular accommodation. It's all nonsense. I don't know why it has been taught that way in this much indeed, and because of this most of the students will get confused, right? So don't confuse with this spectacle accommodation. You can imagine this spectacle accommodation as it is like, see, this is your wife, this is considered to be your wife, and this is considered to be your imaginary girlfriend, which really doesn't exist. And first things you have considered this as spectacle accommodation as an imaginary girlfriend. So first in your mind it has been created, and then you are comparing with this your wife. So this wife really exists, but this doesn't exist. So don't compare with these all things. But if you have to compare within accommodations, to compare within the ocular accommodations, so within this different types of refractive error, right? I hope this makes sense, and this concept have this lecture has made your concept clear. And at last I want to tell that if you feel this in video or lecture is useful, please do subscribe, like, and share my. Yeah, thank you.